Hi everyone, and welcome to another video where we will be talking about the file infrastructure used by the Autonomous Flight Systems Laboratory at the University of Washington to plan, execute, and analyze data from flight tests. In this video, we're going to talk about the three phases of a flight test and then use an example experiment to illustrate how to properly save and analyze data. We'll show how to set up the necessary infrastructure on a machine so you'll be ready to participate in flight tests for either classwork or research. There are three main phases of a flight test or a field experiment. The first one is flight test preparation, and this is probably the most important of any flight test. During this phase, we plan for the experiment by doing things like generating test cards, assigning duties to test personnel, creating packing lists, generating flight plans, uploading aircraft parameters, and many other tasks. I like to think of this phase as creating the inputs that are needed for the experiment to run smoothly. We need to properly plan to ensure that we have a successful flight test. The old adage that always pops to mind during this phase for me is, failing to plan is planning to fail. The next major phase of a flight test is the actual execution of the experiment, where we generate and archive data. During a flight test, a large amount of disparate data are generated by many different sources. We need to set up a file structure to support the proper archival of all this data so that it can be useful to researchers in the future. The final phase of a flight test is to actually analyze all of that acquired data. This involves processing the raw data so you can draw the proper conclusions from the experiment. Again, I like to think of this as generating the outputs or the results of the experiment during this phase. So, I like to use concrete examples, so let's consider a flight test that was conducted on January 20th of 2018 at our flight test facility in Carnation to illustrate the type of data and file structure that are needed to support a flight test. So, during this flight test, we had three aircraft that were flown. The first was Anakin, which is a Skywalker 1900. The next was Peach, which is a fin-wing Sabre. And the last vehicle that was flown was Plum, which is another fin-wing Sabre. Now, during the flight test, each of these aircraft actually flew multiple flights. Anakin is actually one of our older vehicles, so it flew three flights, and as you can see, the flight numbers are fairly high. These are flights number 137, 138, and 139. For Peach, this was actually its maiden voyage, so this is flight 001 that was conducted during this test. And finally, Plum has had a little bit more time in the saddle, so we had two flights during this mission, flights 017 and 018. Now, each of these vehicles or all these flights might contain specialized or different data sets. So for example, with Anakin on flight number 137, we might gather the normal data sets, which are shown there in black, things like data flash logs. We might also take pictures or movies during the flight, and we also collect telemetry logs. But during this particular flight, maybe we put on a specialized sensor like a Pixhawk Mini that was used for different types of data collection. So I'm going to denote some of these specialized sensors in red here. During the very next flight, we might actually swap out that sensor and put on a different system. So on flight 138, in addition to the normal or the black data, we switched and created a vision system that is now flying on board the aircraft, and we're collecting data for that specialized system during this flight as well. And as you can imagine, this process might repeat for all of these different flights and for all of these different aircraft, where you might have some data that's the same format, but you also might have different sensors or different data streams. So as you can see, the amount of data that's generated during a flight test is fairly large, can be dissimilar, and requires a nested file structure to properly archive all of this information. So let's talk about the file structure that's needed for a flight test. When talking about the file structure, the important thing to remember is that the lab has many developers working on many different machines. For example, some people might be working on computers in the lab, whereas others work at home on their personal computers. We need to set up an environment that allows multiple developers to collaborate during all phases of a flight test. To do this, we utilize a system where data is stored in the cloud, and developers can download appropriate files as needed. To do this, we actually use two servers. The first is your typical Perforce server that I'm sure everyone is familiar with at this point. If you're not, please take a moment to go back and review a couple of other videos that we've put together that show how the Perforce server is set up and how it can be used. Now, in addition to the Perforce server, we also have a network drive. And now, these two different systems house different files, although their file structure is fairly similar. Let's start by examining the Perforce server. So the Perforce server, as you know, has many different depots. The one that you're probably most interested for this discussion is the Flight Operations Depot. Inside the Flight Operations Depot, there's a folder called Operations, and within that folder is another folder called Missions. Now, the Missions folder contains all of the different flight tests that we've done from the lab. Each one of these flight tests are given its own folder using the format year, month, day, and a short description of the flight test. Now we saw each one of these flight tests might have multiple vehicles, so within each of these folders there should be a single folder for each aircraft that's participating in the flight test. Again, thinking back to the previous example where a given aircraft might actually fly multiple flights, there should be a single folder within the aircraft folder. Each one of these folders should contain the flight that it's designated for. Again, delving one more layer deeper, within the flight folder, you can put objects or other subfolders to contain the different inputs needed for that very specific flight or experiment. So for example, you might need to put files full of waypoints or aircraft parameters or other relevant inputs for that specific test. Now, let's go back up a level. In the mission folder, there's also another folder called Data Analysis. We'll talk about this later during the third phase of the flight test, but as you can probably imagine by the name, what's going to go in this folder is a lot of different scripts or code or anything that's needed to analyze some of the data that will be generated during this flight test. The other folder that is very critical during this entire process is there's a folder called Robocopy, and inside this folder there are a bunch of different scripts. Each one of these scripts are effectively a Robocopy script which will download files from the network drive to the local machine, and we're going to talk about that in just a second. Finally, the last most important document that is held inside a flight test folder is something called missiondocument.docx. From the file extension, you can probably guess that this is a Microsoft Word file, and this is effectively our test plan. This mission document will contain things like packing lists, test cards, assignments of jobs. It's our Rosetta Stone where everyone can go to and look at to discover what are we trying to accomplish during this test, and we can record other parameters that are relevant to that particular flight test. Now, let's take a look over at the network drive. The network drive has a very similar file structure. In fact, it looks almost identical to the Perforce server. There's going to be a folder called Flight Operations. Within that, there's something called Operations. Within that, there's Missions. And within that, there are a bunch of different folders for each particular test. Now, this is where it differs slightly. The network drive contains different files and different data than the Perforce server. So on the network drive, we are going to stick up lots of larger files. So for example, there might just be general mission data. For example, you take a lot of publicity photos during this excursion. Those could go in this folder. The one that really matters is the raw data folder. And within this, as we saw in the previous slide, each aircraft can fly multiple flights, and they might have different sensors. All of these things are generating different sets of data. So within the raw data folder, there will be multiple subfolders categorized by UAS, or the aircraft, and then further categorized by the flight, and then finally, lastly, categorized by the type of sensor or file that is being stored. Lastly, within the mission folder on the network drive, there's a subfolder called Reduce Data, which is effectively going to be containing things that are generated out of the data analysis or the last phase of a flight test. So again, this is the overall file structure between both the Perforce server and the network drive. The difference being the Perforce server is used to hold small dynamic files. So if you remember, Perforce is a version control system which actually never deletes a file completely, right? It keeps files for all time. And as such, we actually have limited storage space on this Perforce server, only around half a terabyte. So as you can probably imagine, we can't be storing giant data sets on the Perforce server because it's just not an efficient use of space. Therefore, we just use a Perforce server for these small files that are dynamic in the sense that many people need to touch them and change them either in the planning phase or the test execution phase. The network drive, in contrast, is used for large static data sets. In other words, all of the data that's generated or acquired during a flight test, this could be gigabytes of information from cameras, LiDARs, different types of sensors, different flights, different UAS. So as you can imagine, there is a huge amount of data which never really changes. As such, we don't need to put this under version control on the Perforce server. That's what we use this giant network drive to do. So again, the thing to think about here is, again, the Perforce server is used for small files which change a lot, and the network drive is used for large static data sets. Again, these are the setup that's set in the cloud right now that people can now coordinate with and download. So on a developer's local machine, as you can probably imagine, you can easily set up some root on your machine and sync the Perforce depot that we just talked about. So you can have an exact copy of the flight operations depot from the Perforce server and copy down onto your local machine, where you can make changes as you normally would using the Perforce workflow. I drew this as a two-way arrow here, meaning that any changes you make on your local machine eventually will get synced back up to the Perforce server. At the same token, other developers can make changes and you can download these changes. So again, Perforce is a really good way to sync up multiple developers and allow you to collaborate on the test planning and the test execution phase of the flight test. However, the network drive, you only want to actually copy down certain files that are relevant that you care about. So I've drawn this as a one-directional arrow, meaning that you actually never want to modify things on the network drive. You're going to have to coordinate with an administrator to make sure that the data is archived on the network drive, but once it's up there, we want to think about that staying up there and nobody touching it. Instead, what you're going to do is you're going to use that Robocopy script that we talked about a little earlier in order to copy down specific files that you need for your data analysis or for future phases of this test campaign. Okay. So let's see what this looks like on my machine. Why don't we start with the Perforce side? So why don't I go ahead and open up Windows Explorer and I will drag it over here and let's take a look at my Perforce root here. As you can see right here, I've synced a lot of different depots from the Perforce server, but the one that's relevant to this discussion, as we see over here, is the flight operations depot, which I can see right here. And if I go into it, there's the operations, missions, and here are all of the different missions that we've conducted through the lab. The one I want for this example was a flight test that was conducted in January of 2018. So let's scroll down there and we can find it right there. And again, if I open this up, we see that here's the mission document that we were talking about earlier. This is that critical file. If I open it up and look at it, we see that the mission document is basically our planning document, which outlines what we're trying to accomplish, what were the conditions, timelines. All of this information is located in this one document, and people can collaborate on it easily using Perforce. Why don't we close that and take a look again? As we saw and discussed earlier, each aircraft has its own folder. And each of these aircraft, if you go in and look at it, have a folder which detail what is going to happen on each one of these flights that we're going to conduct during a flight test. So if I look into this folder, we'll see that there are things like we can upload objects to represent the geofence, or different polygons that are relevant, or different flight paths for that specific flight. So this is what it looks like in Perforce. Why don't I come back up again to the mission level here, and we'll see. Here's what the Perforce file structure looks like for a given mission. Now, if we look at the network drive, I will do a very similar thing and open up Windows Explorer here, and I will come here to my computer, and you'll see that I've mapped that network drive. Here's that IP address that we talked about here, and there's a shared folder called AFSL shared, which has all of our information from our lab on this giant multi-terabyte network drive. So again, if I open this up, and take a look, we see that the file structure on the network drive mirrors the file structure on Perforce. So if I want to find data for this particular flight test, I would go to the same location. I would go to Flight Operations, Operations, Missions, and find the mission, which is January of 2018, down here. There it is. And again, here's all that information we talked about. So the one that's probably most relevant would be here, raw data. And we see that each one of these aircraft, here's Anakin, Peach, and Plum. Each one of them have data. And if we start digging into this, I can see that, okay, here's Anakin. Here's data that was generated on all of these different flights. Why don't we dig into flight 138, for example? And we see that, yes, we collected data flash logs, we collected some Google Earth imagery, we collected some pictures, we got some information from the Pixhawk Mini, we got some telemetry logs, and finally we got some other data from this vision system. So you can see that there are different sets of data in these two different locations, but both of them are accessible to all developers. So let's talk about how we're actually going to get data from the network drive onto my local machine so I can actually start doing some analysis and looking at what happened during a given flight test. To better understand this, why don't I go ahead and close these two Windows Explorer windows and come back to the diagram we have back here. So what I want to do now is I'm going to use this Robocopy script from Perforce to download only the information I want from the network drive to a very specific location on my local machine. Namely, it's going to download the necessary and desired files to C/K-drive copy. The reason it's called K-drive copy is because I've assumed that you've mapped the network drive here to the K drive on your local machine. So again, if we come over here to my Perforce root here, and let me drag the file over here and take a look. And again, let's go find the folder we were looking for. Again, Flight Operations, Operations, Missions, and the one I wanted was down here. Again, if you look here in the Robocopy folder, you'll see that there is a script in here called Copy K Drive to C Drive. And if I right-click and take a look at what's in here, you'll see that what this script does is that it copies specific data, the ones that I care about, from the K drive here to the C K drive copy here. So let me close this script here, and I'll open up another Windows Explorer menu, and come here to the C drive. And if you look, I've actually already got a folder here called K-Drive Copy. And if I go to Flight Operations, Operations, Missions, you see I've done this before and I've downloaded some data here, but I don't have the information from the particular flight test on January 20th of 2018. Now, if I run this command here, because I've already mapped my network drive appropriately, let me go ahead and start that script, and you'll see here that it's starting to download the information from the network drive, and you see it show up right there on my C drive on my machine. So why don't we give this a couple of minutes to complete, and when we come back, hopefully this folder in C K drive copy has got all of the necessary information that I need for this particular flight test so I can start analyzing the data. So I'll catch you back here in a couple of minutes once this is completed. Great, so now that we've got that data from the network drive downloaded onto my local machine, let's go ahead and do some analysis on that data. So in order to do that, let's come back over to my Perforce side. I'll go up a level, and I'll take a look here in the data analysis folder. So as you can see, I already have some scripts set up. So if I want to make some edits to these, I should probably go to Perforce and check out the appropriate file here. So let's go ahead and open Perforce. I'll start a new change list. Let's call this Performing Data Analysis for the January 20th, 2018 flight test. And I'll go ahead and save this change list, and I'll go ahead and find the file I want under Flight Operations, Operations, Missions. I'll find the January 1 of 2018 folder right there, find data analysis, and here's the file I want to change. This is the MATLAB script that I want to update. So I will check it out, and I'll go ahead and open this up in MATLAB. Let's bring this over here, and just to illustrate the fact that what is important here is now that I've checked out this file, I can go ahead and make edits to the file. And the thing that's important to notice here is in all of your data analysis, we are referencing here that absolute file path of the CK drive copy location. In other words, we're referencing the data that we downloaded off of the network drive onto our local machine into this very specific location. So if you set everything up correctly, now I can go ahead and run this script, and it should use the data that we just downloaded off the network drive, perform whatever analysis that you care about, and generate the necessary outputs. So in this case, for example, let's pull over one of these plots here, and I can just show you that, yeah, we are actually analyzing, for example, the altitude of the aircraft, and we can do things like looking at the trajectory of the aircraft. And basically, we now have a workflow which will allow us to look at, analyze, and process all of the data from this flight test. Okay, so with that, why don't we go ahead and summarize what we covered today here. So, some of the prerequisites in order to use this file infrastructure for our flight tests is that, one, you need to ensure that you're syncing the flight operations depot in Perforce. Two, you then need to map the AFSL shared folder of the network drive to your local machine, and you should map this as the K drive. Once you've done that, you're basically set up to participate in flight operations and flight testing. Again, the three phases that went along with each flight test were, first, we did flight test preparation. Now, what is going to happen during this phase is, as we talked about, first, you're going to be editing the appropriate documents in Perforce. These appropriate documents are things like you'll probably be making modifications to the mission document, aka you'll be generating test cards, packing lists, timelines. All of that stuff can go into this, and all of this can be edited in Perforce. The other thing you're going to want to do in Perforce here is upload planned inputs to this flight test. This would be things like flight paths, polygons, etc. Once you've done all that, you're also going to want to coordinate with an AFSL administrator to create file structure for this mission on the network drive here, right? This is just going to be an empty file structure which will be able to hold all of the information, all the data that we're going to generate during the flight test. The second phase of a flight test is the actual test execution and data archival step. Again, during this step, what you're going to want to do here is edit the appropriate documents in Perforce. Again, these appropriate documents are, during a flight test, you're going to want to be adding notes to the mission document to make sure that we can capture what actually occurred during a given experiment. You're also going to want to do things like update aircraft flight logs so that we know which aircraft flew which flights and what occurred during each one of these flights. Finally, one thing you might also need to do, I'm sure everyone has been to a flight test or seen that things change when you're out in the field and things might not always go according to plan. If that happens, it's very important to ensure that all of the inputs to this experiment, aka the flight paths, the polygons, etc., they have to reflect what was actually flown. So this might require some rearranging of the folders within the Perforce workspace, but at the end of the day, whatever you do, we want to make sure that that Perforce folder accurately reflects what was actually conducted during the flight test. Now, during this flight test, again, you're going to be generating tons of information and data. You're then going to have to work with an AFSL administrator to upload all of this flight test data to the network drive. Remember, you actually don't have direct access to the network drive. Remember in the diagram previously, we drew this as a one-way arrow. Only certain AFSL administrators are going to be able to push data up to that drive. The other thing to think about here is when you are uploading data to the network drive, you really want to make sure that you include appropriate metadata. Think about this. You're going to be flying a flight during a test, and this thing might have a bunch of information, say pictures. Now, if you take all of these pictures and you want to archive them and then pick them up again in 6 months, 9 months, a year down the road, it's going to be very hard to understand or remember what all this information is without all the necessary context. So sometimes it's a little bit helpful to put a small README file or some appropriate metadata in that same folder so that when you upload the data, there's also information and context associated with what is this data and what is its significance. Finally, the last phase of a given flight test here was the data analysis. What you're going to want to do during this phase is, again, edit appropriate documents in Perforce. So first you're going to have to go ahead and update that Robocopy script that we saw earlier. You want to update it so that it downloads the appropriate information from the network drive to your local machine. You usually probably don't want to download all of the information. You only need certain bits, so you want to make sure this Robocopy script is appropriate and intelligent and will pull down only the necessary information. Once you do that, you're going to go ahead and just run that Robocopy script to copy files off of the network drive down to this very specific location, namely CK drive copy. And then you've got the data on your local machine. You're free to go ahead and then perform data analysis as long as you make sure that whatever code or software you write targets those files in CK drive copy. So, with that, I hope this video was useful and helps you understand a little bit about the file infrastructure and settings and software that we use here to conduct flight tests at the Autonomous Flight Systems Laboratory. Thank you so much, everyone, and we'll catch you on the next video.